Your light just shut off, but the battery says it's still half full. Your camera randomly powers down in the middle of shoots for no reason. That's not some glitch, that's your battery tapping out. Most creators never learn how watt hours, voltage, and current actually work. And that's exactly why your gear keeps flaking out when it matters most. I'm Ross from Core SWX, and I've spent 20 years of my career solving these problems for top productions. So let me break it all down. Simple, no fluff, so you stop getting burned by your power when it matters most. Stick around, I've got a lot to share with you. Okay, so I am very excited to make this video. It's something I've been waiting for a very long time. And let's be real, battery specs are confusing. Watt hours, amps, volts, most people either ignore them or completely misunderstand what they actually mean. And for those of you who don't know who I am, my name is Ross. I'm CEO of Core SWX. And for 20 years, I've been deep in the world of professional battery tech, both on the broadcast side and the cinema side. I've worked with major productions, top DPs, and camera teams across the industry, as well as equipment manufacturers, solving real-world power problems. And now what I want to do is break it all down for you. Whether you're a creator, a filmmaker, or anyone that's ever built a rig who was confused about why their camera's shut down, why these lights are shutting down, or why is everything just not working well. So this is a video I wish existed years ago, but let's get into it. So let's start with the big one, watt hours. This is probably the most common number you will see when you're buying a battery, especially in pro video. But even when you look at some of the smaller power banks, sometimes they will list watt hours, but mostly they'll list amp hours. And there may or may not be a reason for that, but we'll get into that in a little bit. So your wattage or your watt hours is simply a calculation by multiplying a battery's nominal voltage by its design amperage. What's nominal voltage? What's design amperage? Just hang tight. We'll break it all down in a minute. For now, think of watt hours as the total amount of energy a battery can store. It's basically your fuel tank. So one of the most common points of confusion amongst people is the difference between watt hours and wattage, because it's not the same. Watt hours refers to your battery's fuel tank, how much energy it can store. Wattage refers to the power your device is pulling right now. So when you have this monitor, or this lighting ballast, or this camera, or this camera, they all pull wattage. So that means this 98 watt hour pack can in theory deliver 98 watts for 1 hour, or 49 watts for 2 hours, and so on. But here's the catch. That only works if the battery is actually capable of delivering that much power in the first place. That's where people run into trouble, and that's what we'll get into. For now, just remember, watt hours equals how much energy the battery can store. That's why a 300 watt hour battery pack is physically larger than a 100 watt hour battery pack. Makes sense, right? Now there are a few exceptions depending on cell configuration, chemistry, and energy density, but that's a deeper topic for another video. For now, let's move on to voltage. So let's talk about voltage. It's probably the most important and most misunderstood part of battery specs. Voltage is like electrical pressure. If amps are the flow, voltage is the push behind that flow. Seems simple, right? But here's the thing. A battery doesn't have just one voltage. It operates across a range, and that range depends on the battery's chemistry, its cell configuration, and the range is dependent on how much charge the battery pack has right now. Now, when you see the term nominal voltage, that's the middle ground, the average voltage the battery sits at during typical use. It's not the full charge voltage, and certainly not the empty voltage either. You may also hear terms like mean voltage or design voltage. While they're not exactly the same, they're close enough that they're often used interchangeably in casual conversation. Now, if you take, for instance, this single lithium-ion cell, fully charged, it's at 4.2 volts. fully discharged, it's around 3 volts. So the nominal voltage is roughly 3.6 to 3.7 volts per cell. It's the middle ground. Now this 4-cell series pack, which is a standard 14.4 volt pack, runs from 12 volts at the low end all the way up to 16.8 volts fully charged. And that range, it matters. Too low and your gear might not even turn on. Too high and you could damage your gear, sometimes fry a component. You hear terms like, I just smoked my gear. That's why understanding voltage isn't just about compatibility, it's about safety. You also need to consider the discharge curve. Voltage just doesn't drop in a straight linear line. It holds steady through most of the runtime and then drops fast near the end. So that 14.4 volt pack might still be putting out 14 volts halfway through use. But once it hits the tail end, you better get another pack ready because it's going to fall off quick. And that's when things start glitching, flickering, or shutting down. And here's where people get tripped up. Let's say your equipment manual says 12 volt input or 14.4 volt compatible. It doesn't tell you the full story. A lot of the gear, especially lights and monitors, use fixed DC inputs, often based on power adapters that came with it. But when manufacturers throw a battery plate on the back without properly labeling the accepted voltage range, they're basically saying, good luck, go figure it out, or call Core. And we see that a lot, unfortunately. So here's the takeaway. Voltage just isn't a number. It's the foundation of whether your system powers up or it doesn't. And what we're trying to do is make sure you don't fry your gear. So, let's talk about amperage, or amps, which is the flow of electrical current at any given moment. If voltage is the pressure behind the power, amperage is the volume, and it's how much current is actually moving through your system right now. Now you'll see something called amp hours, or AH, listed on the battery, and that's completely different. Amp hours measures capacity. It's the total amount of the current the battery can deliver over time, like this cell. So for example, and I say this cautiously just for the sake of explanation, a 10 amp hour battery pack or cell could theoretically deliver 10 amps for 1 hour, 5 amps for 2 hours, 1 amp for 10 hours, and so on. So what does it all mean? Well, it's pretty straightforward, that part at least. Where it gets tricky is when you try to calculate runtime for your equipment, because manufacturers don't always speak the same language. So take, for instance, this device. It says it draws 24 watts, but others may say it draws 2 amps. So what do? If your battery says 100 watts and your gear draws 25 watts, it's simple. 100 divided by 25 equals 4 hours of runtime. But if your gear says 2 amps, now you have to convert it. How do you do that? Well, you take your watt hour rating, let's say 100 watts, and you divide it by the nominal voltage of the pack to get the amps. Let's just say for easy math, the nominal voltage is 20 volts. 100 watt hours divided by 20 volts is 5 amp hours. Now, as I said before, the equipment drew 2 amps. So you take 5 amp hours and divide it by 2, and you're left with 2.5 hours of runtime. Not so bad when you break it down. But here's where people really mess up, especially with high draw lighting setups, and we see it all the time. They think 10 amp hours means the battery can deliver 10 amps all at once. It's not always the case. And that's where load handling, or C rating, comes in, and that's where reputable manufacturers really can help out. Let me put it like this, with the car analogy. Amp hours is the size of the fuel tank, no different than watt hours. Amps is the amount of fuel flowing through it right now, and load handling is how big your engine actually is to handle the load or draw. If you try to pull more amps than your battery was designed to handle, well, you're in trouble. You're putting excess wear and tear on the battery pack, you're creating more heat, there's voltage sag, performance drop, and worst case, a hard shutdown when you don't want one. Now, if you're buying from a reputable brand, like I said, they should be upfront about this. It's not some hidden spec, that you have to dig through. So look for the ratings, like 10 amp continuous or 12 amp sustained. That's the language you're looking for. And when a trusted manufacturer lists those numbers, you can count on them. That's the actual current the battery can deliver reliably without issues, without deterioration. And that matters, especially when you're running high draw gear and equipment like LED lights and cinema cameras. Because let's be honest, we've seen plenty of questionable ratings out there. Let's just say sometimes the numbers aren't wrong on purpose, but they're definitely not rooted in reality. And just to call this out, you know those USB power banks that we all see online. Why do they average 10,000 milliamps or 30,000 milliamps? They rarely list the voltage or the current that they can actually sustain. And that's not by accident, because most of them can't handle real sustainable load. And they're counting on the fact that you won't ask. You plug your laptop into it, you're good to go. So here's the takeaway. Amps equals how much current is flowing through the system. Amp hours is how long it can flow. And load handling is whether the battery can actually handle the load. And if it can't, all that big capacity on the label won't matter. Your gear could still cut out, glitch, or fail at the worst time. Okay, so I've been doing this for over 20 years and I have a lot to tell you guys. And I'll be diving deeper into a lot of it we touched on today in future videos. But I want to lay a groundwork first so that the next conversations actually make sense. Battery specs shouldn't feel like some black box. They're here to help you build safer, smarter, and more reliable setups. If this helped connecting the dots, go ahead and hit subscribe and drop a comment if there's something specific you want me to unpack next. Until then, power up and do it with confidence.